everyone, this video is about identifying forces, Newton's laws, and free body diagrams. Let's review the types of forces. We have a normal reaction force, the friction force, tension, resistance, braking, driving force. There are all sorts of forces, and Newton's first law, sigma F equals 0. So the object can be stationary or moving with constant velocity. A common misconception is sigma F equals 0 means always stationary. Well, not always. The acceleration must be 0, but the velocity can be non-zero. Newton's second law, sigma F equals ma. The acceleration is not 0, so the velocity is changing. The magnitude or the direction or both are changing. Acceleration can be positive or negative, acceleration, deceleration, acceleration going faster, deceleration going slower. When the acceleration is positive and velocity also positive, this is an acceleration because the direction of acceleration is the same as the direction of the velocity. Or when the acceleration is negative and the velocity is also negative, so this is also an acceleration. For deceleration, the directions are in opposite directions, so positive a, negative v, or negative a, positive v. A common misconception is when the acceleration is positive, it's always acceleration. Well, not always. Here the acceleration is positive, but it's a deceleration because the positive acceleration is in the opposite direction of the negative velocity. Newton's third law, action equals reaction. So the conditions for two forces to be a pair of action-reaction forces are they have to be the same type, work on different bodies in opposite directions, and they have the same magnitude. A common misconception is that normal and weight are action-reaction forces. That is wrong. Common misconception here, we have a box on a horizontal floor. The normal reaction force and weight force are not action-reaction forces because although they have the same magnitude and work in different opposite directions, they are working on the same body. The normal reaction force is holding or pushing the box upwards, and the weight is pulling the box downwards. So they are both working on the box. And same type of force, of course, normal reaction is a contact force. Weight, which is gravitational, is non-contact. So of course there are different type of forces. And another reason why reaction and weight are not action-reaction forces, if we have another little force F pulling the box upwards but still touching the ground, the box is still in contact with the floor. In this case, the magnitude of the normal reaction force is not equal to the weight force. Actually, the normal reaction plus the applied force is equal to the weight force. So the correct pairs of action-reaction forces, for example, a person near the earth, the person doesn't even have to touch the earth actually. So weight, which is gravitational force, this is FPE, FEP. Weight force, which is gravitational force exerted on the person by the earth, which means the earth is pulling the person down, is the pair to this force, also gravitational, on the earth by the person. So the person is also pulling the earth up at the same time actually. Normal reaction force exerted on the wall by the person, so this is a person pushing the wall. As the person is pushing the wall is pushing him back. And this is box suspended on a rope, so we have TRB, TBR, the tension force exerted on the rope by the box. So the box is pulling the rope down and the rope is pulling the box up. So they are working on different bodies. And box, this is a box sliding on rough floor, so we have friction forces here, F. B and BF. Let's say the box is moving to the right, so this means we have friction force exerted on the floor by the box, the green one. So this means the box is trying to push the floor to the right. As the box is sliding to the right, it's trying to push the floor along with the movement of the box here. And the friction force exerted on the box, so this is working on the box because of the floor, is to the left because the box is like pulled back by the floor. Free body diagrams or FBD or force diagrams. This is important to solve complicated questions. We need to know the type of forces working, the direction, the magnitude, and the line of action. Here are some common words you see in the question. And we can simplify FBDs. For example, here we have a box with a parachute. We have 4 tension forces here. We can simplify it into one, just like one tension force. And for the air resistance force, we can just simplify into one simple resistance line. So an example, a coin is balanced on your finger and then it moves upwards. And of course we have the normal reaction and the weight forces. By considering Newton's law, what can you say about W and R in each of these situations? When the coin is stationary, moving upwards with constant velocity, increasing as it moves upwards. So this is accelerated and this is decelerated as it moves upwards. So when the coin is stationary, there is no acceleration, of course. Sigma F equals 0, so the R must be equal to W because there is no resultant force. When the coin is moving upwards but with constant velocity means again there is no acceleration. So although it is moving, but sigma F equals 0 and there's no resultant force, R must be equal to W. Now when the coin is moving upwards and the speed is increasing, so in this case we have resultant force, and the resultant force must be upwards because it is accelerated upwards, so the R must be bigger than W, and therefore the resultant force is R minus W upwards. And when the coin is moving upwards but the speed is decreasing, the velocity is decreasing, this means it is decelerated downwards. So in this case the W is bigger because we have resultant force downwards, because we have acceleration in this direction downwards, and the resultant force is W minus R going down. And another example, we have a pulley, smooth, and rope, light, and so on, block 2 kg, and this is like a sphere 5 kg. Draw diagrams. The block does not slip. Find the tension and the magnitude of friction. Write down the resultant force. Okay, so for I, this is the diagram for A. We have normal force, weight force, friction, and tension. For B, we have the tension force going up and the weight force going down. And this is on the pulley. For the pulley, we have tension to the left and tension downwards. So that means this tension is equal to this tension. And for II, if the block A does not slip, find the tension in the string and calculate the magnitude of the friction of the block. So when the block does not slip, this means we have does not slip here means does not move. So does not move means sigma F equals 0. So the force to the left, which is the friction force, must be equal to the tension force. And 5G here would be the weight force of, yeah, well, we're doing this one first here actually. So forces on B. So since the block does not slip, the block does not move, the rope does not slide on the pulley here, so we have stationary